All right, so we're going to spend a little bit of time going through the fingerprinting the stars explore activity. Um, every time we do an explore, we'll take some time to kind of figure out what we figured out, what we learned, what were we supposed to learn, and how were we supposed to figure that out. Okay, so one of the key things I want you to think about here is the idea of fingerprinting and how important your fingerprint is to your identity, and how different groups of people use fingerprints to determine different things about different individuals. Okay, that was kind of my hint and my clue to you for this particular activity. Okay, so one thing that we're dealing with is this idea of a spectra. And essentially what that is light coming from various different things, stars, whatever the case is. And that light then can travel through something called a spectroscope, which kind of is like a prism. And it takes that light and divides it up into different lines, right? When you take a look at the sunlight through a prism, you see all colors of the rainbow. Okay. Well, with different elements throughout the entire universe, if you do that when you make the element glow, and then you look at that light from a spectroscope, then you can see these different lines. And the really cool thing is that each of these different elements has its own unique set of spectral lines. Okay, and that is extremely helpful when it comes to astronomy. Because when we're trying to determine information about stars, especially their composition, we can't go there. These things are so far away, but we do get a clue when it comes to these spectral lines. Okay, and that's kind of the point of this activity, is what information can we get from this light to tell us about stars? Okay, so your first activity was to determine the chemical composition of stars 1 through 5 using worksheets 1 and 2. Okay, the answers are up on the screen, so please pause the video and correct your explore activity. Okay, so pause it, and then I'll keep going here. Okay, so what I wanted to do is walk through this process, because it is a little bit kind of time intensive, but then also to try to get at some of the important content. Okay, so I'm going to start, I'm going to go through star 1. So star 1, as you can see, has hydrogen, lithium, and helium. Okay, well, how did we figure that out? Okay, so when we take a look at worksheet 1, okay, what they're showing you with each of these different spectra is the emission lines for that specific element. Okay, and every element has its own unique set of spectral lines. And because they're unique, if we see them in a star, and we see all of these for hydrogen or whatever element it is, and they all match up somewhere in the star spectra, well, then that star has hydrogen in it. So what I did to make this a little bit easier is I color-coded each of the different lines, and then figure out where they were. I used the angstroms down here to help me with that. Then I went down to each star and kind of try to determine if star number 1 had hydrogen in it. And it turns out, based on what we see, every single one of the hydrogen lines match up with a line in the star. Okay, so that means star 1 has hydrogen in it. Okay, I did that same process for lithium, helium, and then also the other elements on here. Okay, and based on where they all match and where they all show up, I was able to determine that those 3 elements are in star 1. Okay, so you might be thinking to yourself, well, Mr. Christman, how does that work? Star 1 has all of these other lines in it, right? And that's true. You're absolutely right. Those lines are coming from other elements. Okay, stars are made up of different and many elements. Okay, we were only given 7 different elements here. Okay, so what that means is all these other lines for star 1 come from elements that are not in our list up there. Okay, which is fine. Okay, all we have to make sure is that every line for hydrogen. Okay, so every single line that we see here has to match somewhere in the right spot in our star. Okay, so that's how that works. All right, obviously some stars have more lines than others, and they have more elements than others. Okay, so that's the process. All right, so that's where we're at with this. Okay, based on the other questions, it's asking you what elements are in every single star. Hopefully you found that hydrogen and helium are in every single star. And the next question was kind of a prediction question. I didn't necessarily think you would know this, but I was hoping that you'd start to think about, okay, well, why would that be? Why would every star in our universe have those two elements? Okay, and hopefully you started to think about, and if you didn't, that's okay. But if all stars have those things, well, then maybe all stars are made of or start with those two things. And if that's what you were thinking, well, then you're right. Okay, stars are these very large balls of extremely hot gases. Okay, hydrogen, helium, they're both gases. Okay, and when stars start to form, they have to form from something, right? And the something that they start with are hydrogen and helium. Okay, the next question deals with what star has all elements, and that would have been star number 2. Okay, so going through that process of matching the elements to the lines in the stars, star 2 had every single one. Okay, moving on to the next one, it says make a prediction about the size and temperature of star number 2, because it has all those elements, so star number 2. Again, don't necessarily think that you were going to get this right away. So change your answers to these two as we go through them. But hydrogen and helium are the lightest elements on the periodic table. Okay, and in order to get bigger and bigger elements, well, what happens is this process of nuclear fusion. Okay, so atoms crashing into each other, or atoms of elements crashing into each other, instead of bouncing away, they fuse and make something bigger. Okay, well, if we look at the elements in star 2, since there's all of them, wrong way, we have things that are much, much heavier than hydrogen and helium. Things like iron and neon. Everything on this list is bigger than hydrogen and helium. Okay, so because the star is made up of bigger things, it needs more mass to do that. Okay, so star number 2 is a very massive star, and in order to fuse things, it needs a lot of energy. So star 2 is also going to be very, very hot in order to smash those things together. Okay. Next question, and this is kind of the core of our assignment. So this is the most important thing to come away with from this fingerprinting. The question is, how is it possible for scientists to know the composition of stars without traveling to them? Okay. Like I said earlier, these stars are light years away from us. Yet, when we look at these stars, we're able to say, yep, that star is made of hydrogen, it has helium, it has some neon, it has iron, and not only that, we're also able to kind of determine the percentages of those different elements. And all of that information, which is crazy to think about, comes from the light that star produces. Astronomers take that light, comes through a telescope, comes through that spectrometer, okay, or the spectroscope, and it divides it all up, okay, and you saw that you had to deal with all of those lines, okay, and the wonderful part, like I said, about the lines is that they're coming from elements that are completely and utterly unique, like your fingerprint, okay? Your fingerprint doesn't match somebody else's, just like the fingerprint of these different elements don't match other elements, okay? So when an astronomer looks at the spectral lines, they use a computer. They just run it through, and it tells them what elements there are in that star without even going to the star. Okay, and then based on the spectral lines for that star, that compilation, right? this right here for star 1, okay, is unique to that star. Okay, no other star is going to have the same set of all of those because they're all kind of evolving and changing as they go through their life. Okay, so these spectral lines are super important and very critical in determining a lot about the stars. That light that we get a lot of information from those stars. Okay, so if you have questions, watch this again. If something still doesn't make sense, please let me know. And hopefully this helped you understand spectral analysis.